Good morning, everybody. I hope you're having a great day, a good, great, grand, wonderful day. Man, happy Thursday. Sorry I don't get to be there, but I want to make sure that you feel very confident about this practice quiz. There is nothing on here that you aren't fully capable of doing. And what I'd like to do is I'm going to work through every problem and hopefully in the process answer any questions that you would have had. But we can take a look at this and see maybe even some of the small mistakes I had made in making this, but otherwise it's going to be relatively simple. So let's dive right in. If you got your quiz, make sure you've got it out right now so we can take a look at what you did, what you should have done, and look at all the things you did right. All right, first of all, on this first problem, notice that we have a series of powers all being raised to a power multiplied by another series of powers being raised to a power. So different ways of looking at this, there's different orders that you could go. So just because you do a different order than me does not mean you did it wrong. It just means that you maybe kind of decided to go one way when I went the other. As long as we end up at the same spot and we didn't break any rules or properties of exponents, we're good. So let's take a look. What I'm going to do is I'm going to just go ahead and kind of deal with this -2 right there. And so I look and go, okay, so let's go ahead and move all of that to the bottom. So I could start by saying, well, this top part will be 2x squared, y to the third, whole thing raised to the third power, while on the bottom, it'll be 4x to the third y, the whole thing squared. All right, and all I did was just deal with the fact that that had a negative. Here on, I could go ahead and distribute that power. We said when we raise powers to a power, we multiply. And so it's almost like distributing. So I realized that this is the same as 2 to the third power, x to the 6th power, because that 2 times that 3 gives me 6, and then y to the 9th power. 3 times 3 is 9. All over 4 squared, and then x to the 6th power, and then y squared. All right. And so at this point, again, I just kind of keep simplifying. And so I say, well, 2 to the third power, that's 8. X to the 6th power just is. Y to the 9th power just is. And then on the bottom, 4 squared is going to be 16. I've got x to the 6th power over y squared. Now, hopefully at this point, you're kind of seeing some of the things that are going to happen. Obviously, we got x to the 6th on the top and on the bottom, so those cancel out. 8 over 6 is the same thing as 1 over 2. And then we've got y to the 9th over y squared. And so really, you go, well, where do you have more y's? You have more y's on top. So you're going to end up with y to the 9 minus 2. I'm just kind of doing it the long way here, over 2. Because this 1 ends up on top right here, and this 2 ends up on the bottom. And so all that simplifies back down, right in blue instead of red, all that simplifies back down to y, hang on a second, y to the 7th over 2. All right, I hope that makes sense. There we go. Y to the 7th over 2. All right, because we ended up with more y's on the top right here than we had on the bottom. And so as we look at that, some of them cancel out. We have the 2 on the bottom from the 8 over 16. Hopefully this is what you got. All right, moving on. 5b. Okay, with 5b, now we've got almost the exact same thing where we've got a lot of powers being raised to powers, and so we got to kind of deal with that. We've got this whole thing on the bottom that's negative, and so just like before, I could go ahead and shift that right from the beginning and make this say 4rs squared, and then bring up and say, and this is the same thing as 2s squared, and that would all be over 2r squared, all raised to the 4th power. Again, I can kind of continue this and go, well, that would be the same thing as 4 squared, r squared, s squared, times 2 squared, s squared, all over 2 to the 4th power and r to the 8th power. All right, on the top, I can go ahead and combine things. 4 squared is 16, r squared, and that's the only r up there, so I'm just going to leave that r squared. And then I have s squared times s squared, which would give me s to the 4th. And then times 2 squared, which is, of course, 4. And maybe I should have went ahead and multiplied the 16 and the 4, but, well, we'll just do that in the next step. All over 2 to the 4th is 16 times r to the 8th. Now, you see the benefit of not multiplying the 16 and the 4 right now, because you realize at this point, those are just going to cancel out right here. All right. So then we look at this and we say, all right, those cancel out. I've got r squared up top, r to the 8th on the bottom. If I subtract those, I'm going to end up with r to the 6th on the bottom. And on the top, so that would take care of these. On the top, what I would have is 4s to the 4th. So 4s to the 4th over r to the 6th should be my final answer. All right, moving on. Let's look at 5C. Now this time, we start with a quotient right from the beginning. We're starting with this huge fraction, but everything's being raised to a power, and notice that that power is negative. So if we're raising everything to a negative power, one of the rules of exponents was that you could just go ahead and flip everything inside and deal with that negative. So that's what I'm going to do. I'm just going to go ahead and rewrite this right from the beginning, say x squared y squared times z all over x to the fifth y to the negative 2 z to the third power. And that whole thing is being squared. I realized that what I did is I dealt with that. I went from being a negative 2 to being a positive 2 by switching and flipping everything inside. Now, I've had some people question about this negative 2 right here and the fact that it's still negative. And that should still be negative because the only thing I did is dealing with this outer negative is what made everything flip. So I got to flip it as it is. And so now I can deal with some of those other exponents, like that negative 2 that's already in there. So that negative 2 is going to jump to the top. I don't know if we can just kind of do this kind of quickly right now, but we can see right here, x squared over x to the fifth is going to leave me with x to the third on the bottom. Y squared over y to the negative 2. Now, some people cancel those out when you shouldn't. That y to the negative 2 jumps to the top. So now on top, I have y to the fourth. And then I have z over z to the third, more z's on the bottom, so I subtract and I get z squared. So all of that simplifies down to here. If, of course, you forget about that outer exponent, as I did, as I'm sure all of you are probably laughing, going, what an idiot he is. So instead of stopping everything and acting like I'm not an idiot, I'll go ahead and work it, realizing that I am. So we're going to get rid of all this for a second, okay? All right, and we're going to go backwards, and we're going to say, well, let's deal with this exponent as I should have. So what if we distribute that exponent, then we're going to end up with x to the fourth, y to the fourth, z squared, all over, let's see here, x to the 10th, y to the negative fourth, z to the 6th. Okay, so now I've dealt with that outer exponent. Now I can simplify everything. Sorry about the confusion. If I lost a couple of people there, I apologize. Okay, all right, so at this point, now I've got the x to the fourth over x to the 10th. So how does that simplify down? Well, that would leave me with x to the 6th on the bottom. I just subtract them. Again, very similar to what we talked about before with the y squared up top and the y to the negative 2. Now I just have y to the fourth and y to the negative 4. And so with that negative 4 makes that y jump up top. I have y to the 8th on the top of the fraction. And then we look and we have z squared over z to the 6th. And that would leave me with z to the 4th in the bottom. All right. So that is the final answer. Sorry about that. We should have y to the 8th over x to the 6th is z to the 4th. Forgot about that outside exponent there for just a second. Okay, moving on. Let's look at number 6. Number 6 is about the easiest rational exponent problem you could possibly be given. I hope you see that just about everything worked out perfect from this. Remembering that when I have powers being raised to a power, I can distribute that to kind of each one of these. And if I do that, then really I'm always multiplying. When you raise a power to a power, you multiply. So x to the 10th, as I multiply into a fraction, you multiply into the top, becomes x to the 30 over 5. All right, y to the 20th becomes y to the 60 over 5. And z to the 15th becomes z to the 45 over 5. And if you're wondering where I got these numbers right here, I'm just multiplying. 10 times 3 gives me 30, 20 times 3 gives me 60, and 15 times 3 gives me 45. And so this is kind of where I get right now, but then all of those fractions reduce. 30 divided by 5, 6. 60 divided by 5 is 12. And 45 divided by 5 is 9. So my final answer is that simple. X to the 6th, y to the 12th, z to the 9th. All right. This next one's not quite as easy, but it's not too much harder. I'm going to go ahead and right from the beginning, let's see, distribute those outer exponents to the inside. I can't really deal with the fact that I've got x to the 6th over x to the 6th yet because I have parentheses around them and other things happening. So that means I'm going to end up with 4 to the 3 halves. And then x to the 6 times 3 is going to be 18 halves. And y to the 4 times 3 is 12 halves. all over 8 to the 2/3, x to the 6 times 2 is 12/3, and y to the 8 times 2 is 16/3. All right, at this point, most of those fractions go away. I can think about 4 to the 3/2. Well, that's the same thing as 4 raised to the 3rd power, which is 64. 4 times 4 is 16, times 4 is 64. And then I got to take the square root of that. Okay, so the square root of 64 is 8. So I could kind of realize that if I know what this is, I could either write it and say, well, I know that's the same thing as the square root of 64, or maybe I just jump all the way ahead and say, I realize that 4 to the 3/2 power would be 8. All right. And then x to the 18/2 power is going to be the same thing as x to the 9th power. Y to the 12/2 power is going to be y to the 6th. And then 8 to the 2/3. So now let's think about this. We go 8 squared, because I got to deal with that top one. 8 squared is 64. And the cubed root of 64 is 4. We kind of saw that a second ago. Then you got x to the 12/3. 12 divided by 3 is 4. And y to the 16/3, unfortunately, that doesn't come out clean. But there's something going on there. We go, well, that's like, if we were going to make it a mixed number, that's like, 5 1/3. And so for just a second, we might want to even think about it that way. We never would write it like that because that's just absolutely terrible. But we could kind of think about it that way. So I'm going to leave it as y to the 16/3. Okay, and now let's reduce this thing. 8 over 4 is clearly 2. X to the 9th over x to the 4th leaves x to the 5th up top. And then on this last part, we have y to the 6th up top, and we have 16/3 at the bottom. So to subtract those, I would have to think about common denominators, okay? And so we'd go with 6 is how many thirds? Well, you multiply it by 3 over 3, and you get 18/3. So 6, I wrote 18, 6, 18/3. So 6 is the same thing as 18/3. So this would really be y to the 18/3 over y to the 16/3. And at that point, you subtract those. And so I'm left with, let's see here, 2x to the 5th. I've got y to the 18/3 minus, 18/3 minus 16/3, and that would give me y to the 2/3. And that looks a whole lot nicer. That came out real simple and clean. Okay, 2x to the 5th, y to the 2/3. All right, moving on. Let's keep going. So now I want to see if you can find the differences between 7a and 7b. All right, look closely at them and tell me what is different from 7a to 7b. Of course, the answer is nothing. All right, that was a typo. I wrote the exact same problem, so I don't need to do it twice. All right, but what we're looking here is we're just trying to remember the rules and properties of radicals and different ways to look at this. If I wanted to really break this down to try to help people understand, I'd go x to the 7th is the same thing as x times x times x times x times x. And then y to the 4th would be y times y times y times y. And z to the 8th, oh my goodness, would be 1, 2, 3, 4, 5, 6, 7, 8. All right, and notice we have, this is all the cubed root. And what that means is it takes 3 of them for them to come out. So I could go, well, here's 1, 2, 3, so an x gets to come out. And then another 1, 2, 3, so that x becomes x squared. But there's 1 left inside. For the y's, I'd go 1, 2, 3, and a y gets to come out. But again, there's 1 left inside. For the z's, I've got 1, 2, 3, so a z gets to come out. 1, 2, 3, so then I get to square it, and there's 2 left inside, okay? So if we were going to write this in terms of radicals, our final answer would be x squared y z squared times the cubed root of everything that's left inside, x, y, z squared, okay? Now, if you wrote it as rational exponents, there's nothing wrong with that. I mean, that's actually really simple, but I want to make sure we still understand the basics of radicals. And so that's why the directions on this one didn't ask you to write it specifically as a rational I'm sorry, as I'm saying that, I realize, of course, I'm lying. It says go ahead and write it as rational exponents. And so this is a great way for us to see how to deal with radicals. But if we're going to write it as rational exponents, man, let's really fast track this thing. Okay, so here I'll take this and scoot this down here, and watch how fast this is if I just write it as a rational exponent. All right, I realize that this is going to be my denominator, and so I just go x to the 7/3, y to the 4/3, and z to the 8/3. And if somebody asks, well, where did you get this 7, 4, and 8? Right here. And where did these 3's come from? Right here. And so clearly, you can see that this was definitely the fast way to go. I do want people to make sure that they understand how radicals work, but this is a great time to see the connection between radicals and rational exponents. All right, moving on, 7b, or 7c now. This one, hopefully it looked a little bit familiar. We actually saw this one before, so hopefully you kind of got to this one and went, oh, I think I can work this one. So you go 5 to the cube root, or 5 times the cube root of x, would be the same thing as 5x to the 1/3, and then 3 times the 4th root of x would be 3x to the 1/4. Well, 5 times 3 is 15. And then we've got x to the 1/3 times x to the 1/4. And just like we've said many times over, if we have x to the a times x to the b, that's going to be x to the a plus b. In other words, if I have x squared times x to the 5th, it's not x to the 10th, but it's x to the 7th. And so right here, I have to find a common denominator and add those exponents. So this is x to the, now obviously 3 and 4, the common denominator is 12ths. So I can multiply the top and bottom of this one by 4 and get 4/12 times x to the 3/12. And when I combine those, I get 15x to the 7/12. Simple, easy problem. All right, now let's see how hard we can make this. And 7D, again, we saw this one or one very similar to this before, so hopefully this was not too overwhelming for you. We look at this and we can do this a couple different ways. One of the ways I can look at it and say, well, this is the same thing as x, y, all raised to the 1/2 over 16xy, all raised to the 1/4. You know, we want to talk about common denominators, and so this is where I did this problem a couple different ways, and some people thought it was way easier one way, and other people thought it was way easier the other way. And so this is, you know, take it and do it how you want, as long as you're doing it right. I could look and say, well, let's talk about common denominators. This would be the same thing as xy raised to the 2/4 over 16xy raised to the 1/4. Everything is the exact same. All I did was change the 1/2 to 2/4. So no big deal. But then with that, I can go, wait a minute. So this is all now fourths. And so really one way of looking at it, it's all the 4th root. Okay, and maybe I need to kind of step back one and go, this would be the 4th root of xy squared over the 4th root of 16xy. And if I realize that, I know the properties of radicals say, well, then you can combine that to one massive 4th root and say the 4th root of xy quantity squared over the 4th root of 16xy. And then from there, you can say, well, I know that the top of that, so I have the 4th root, that's just going to be x squared y squared over 16xy, and now a bunch of things start to cancel out. You realize, you go, well, the squareds would cancel out with the xy down here, and so I would be left with what at that point but the 4th root of xy over 16. And I know what the 4th root of 16 is. It's 2. And so that part actually comes out, because again, what I can do is I can now kind of go back, think about going back to like a step like this. Remember, we said if you have one big radical of a fraction, you can break it up into 2 radicals, which is what we have up there. And so that's what we could do right here. We say, well, then that's the same thing as the 4th root of xy over the 4th root of 16. And that's then easy to solve. We have the 4th root of xy over the 4th root of 16 is 2. And then it said, hey, write it as a rational exponent. So that would be xy to the 1/4 over 2. Now, that was one of the ways I did this problem, and that confused the heck out of some people. And other people, they loved it. They thought that was a really good way of looking at it. And so now what I want to do is I want to take a look at a completely different way, and hopefully you kind of figure out which way you want. Either way, that's the answer we're going to get. So I'm going to go ahead and kind of save that. Boom. Save that off to the side here. Boom. Let's get rid of all that. Okay, so we're going to talk about another way we could have done this. Well, right from the get-go, what I did was I converted them to rational exponents like this. And 16xy raised to 1/4. And I could have gone ahead and, as I did, find that common denominator, xy to the 2/4 over 16xy to the 1/4. Notice I'm keeping them in parentheses, because otherwise only the last term would be raised to that exponent. And this could then be x to the 2/4, y to the 2/4 over 16 to the 1/4, x to the 1/4, y to the 1/4. And the reason why I do that is because then I can do easy subtraction. All right, because I have exponents with the same, or powers with the same base right here, x and x, and same base right here, y and y. And so I can just subtract those. And that would be then equal to x to the 2/4 minus, x to the 2/4 minus 1/4 is just going to leave x to the 1/4 up top. And then y to the 2/4, and then over y to the 1/4, I subtract those. And I get y to the 1/4 up top. And then all on the bottom, I have 16 to the 1/4, which I know. 16 to the 1/4 is 2. And then if I want to make this just a little bit nicer looking, I might go ahead and kind of combine those back and say, well, that's the same thing as xy to the 1/4 all over 2. Either of these answers, this one right here and this one right here, would be acceptable. Okay, and to some of you, that might be an easier way. You know, the fact that we kept it as rational exponents, we found that common denominator, we distributed it, kind of made a pretty big mess at first, but then that simplified down really fast. But we would have to leave it, you know, as one of these to get a final answer. All right. Okay, let's move on. Here we go. Rationalizing denominators. This was something we talked about yesterday, and we talked about, or a couple days ago, talked about how easy this is. Okay. Let's see. And so you might not remember how to do these. And so it might have been a while, so I want to make sure that you feel good about these. Rationalizing denominators is just way too easy. Okay, typically, if I have something that says, let's say it has 5 over the square root of 2. Hopefully somebody in here remembers that all I have to do is multiply the top and bottom of that fraction by square root of 2, because any number over itself is 1. So any number over itself is 1. So I can multiply this by 1 and it doesn't change the value. And that would give me 5 times the square root of 2 over the square root of 2 times the square root of 2, which is 2. So it says 5 times the square root of 2 over 2. Now this is the whole point of rationalizing a denominator. The denominator went from an irrational value to a rational value. And so we went from here to here, but ultimately those two things have the same value overall. 5 over the square root of 2 is the exact same value as 5 times square root of 2 over 2. Those have the exact same value. So typically when we think about rationalizing denominators, we're just multiplying the top and bottom by whatever that radical is. And that's really simple, okay? And that's kind of where we probably, in Algebra 2, that's the thing you remember the most. But here, what I want to show you is I want to compare that to what we've been doing with this idea of rational exponents, or these exponents with radicals in them, okay? And so let's kind of think about that for a second. What if I have something very similar, and I say 5 over the, we'll go with the exact same, 5 over the square root of x. Well, as a rational exponent, that would be 5 over 2 to the 1/2. And we think about this. I want that 2 to just be 2 to the first power. So what do I need to do to the top and bottom? Well, in this case, I'd multiply the top by 2 to the 1/2 and the bottom by 2 to the 1/2. And you think about that. When I multiply these two, you have to add the exponents, the 1/2 and the 1/2. And what do I get? I get 1 whole. Now, I cannot multiply these two things together. I can't multiply something with an exponent and something without an exponent that had different bases. So don't start thinking that's 10 to the 1/2. But what that would be over here is that would be 5 times 2 to the 1/2 over 2 to the 1 whole. And so the reason why I show you this is sometimes figuring out how to rationalize a denominator is easier when we think about fractions. It might not have been in this case, but I can definitely show you one where it would be. If we had something almost the exact same, but I changed one part about it, if all I did was say, well, let's say we're doing 5 over the cubed root of x, or cubed root rather, of 2. Now, a lot of people go, oh, you just multiply the top and bottom by the cubed root of 2. But the problem with that is I get 5 times the cubed root of 2 over, look at what's on the bottom, the cubed root of 2 times 2. And on that problem up here, we talked about how you needed, whatever this number is, you need that many for that value to come out. And so we run into that problem here. This is a cubed root, but I only have 2 of these things, so they don't get to come out. So I actually have to then do that again and multiply by the cubed root of 2 again. And now I've got 5 times the cubed root of 2 times 2, which would be 4, over 2. And that became kind of messy. But now if I look at that in terms of rational exponents, it's actually really easy. I'd say 5 over the cubed root of 2 is the same thing as 5 over 2 to the 1/3. And all I have to do is ask myself, well, what do I have to multiply the top and bottom by to make that value, that 1/3, a whole? And it would be 2/3. So I'd multiply the top and bottom by 2 to the 2/3. And that becomes 5 times 2 to the 2/3 over 2 to the 1 whole. Okay? And I know you're probably dying to multiply these two things together, but you can't unless they have the same base. All right? It's like multiplying an x and a y. It just stays x times y. But you can see when we have a fractional exponent, it really can make some things nice. All right? So now, with all that said, let's take a look at these problems. Okay? So obviously this first one is just so simple. All we have to do, like we said before, is we multiply the top and bottom by the square root of 3. And we get 6 times the square root of 3 over 3. And even better, some of that breaks down because 6 over 3 is 2. And so it simplifies down to something that's not even a fraction. 6 over the square root of 3 is the same thing as 2 times the square root of 3. All right, now let's look at this other one. This has that cubed root. Definitely a good time that we want to start thinking about in terms of rational exponents. So this is the same thing as 3 over 3 to the 1/3 power and x to the 2/3 power. And why did that do that? Because the 3 did not have an exponent, but the x did. So that's why it's to the 2/3. And now I just have to think, well, what do I have to multiply on the bottom and top so that the bottom becomes a whole number exponents? You go, well, I need 2/3 on the, I gotta have 3 times 3 to the 2/3 times x to the 1/3. Now if I do that on the top and bottom, on the bottom I'd have 3 to the 1/3 times 3 to the 2/3 times x to the 2/3 times x to the 1/3, okay? And now all those combine. And so on the top, I'm just gonna leave that alone for a second, say 3 times 3 to the 2/3 times x to the 1/3. And now on the bottom, I realize that all that comes together and it's just over 3x. Now, good news. Some of that cancels out. Okay, these two terms right here, I've got a 3 on the top and a 3 on the bottom all by itself. Those cancel out. And so then this whole thing reduces to 3 to the 2/3 x to the 1/3 over x. All right? It's that simple. If you happen to have written it as the cubed root of 3 squared x over 3, that would be completely acceptable. Or if you even dealt with that 3 squared and made that the cubed root of 9x over 3, that's completely acceptable. Any one of these 3 answers would be fine. But that's where you want to get. The whole point is that you get, oh, sorry, I put a 3 on the bottom of those. That was wrong. Okay, that was supposed to have an x on the bottom. Sorry. Hopefully I'm catching all the mistakes I'm making and you guys aren't yelling at the screen going, wait, you made another mistake here. So either one of these three answers is completely acceptable. You could have left it like this, or like this, or like this. It's okay. All right, moving on. Now we go to the back side of this. Now the back side this is the really easy stuff. This is we're just simplifying some of these algebraic expressions. We got to use the properties of exponents and radicals. This is simple, okay? So let's try to roll through these pretty quickly because I don't think there's a whole lot of work to them. All right, so let's take a look. This first one says the fifth root of x times x squared minus 2. Well, let's think about how would we want to do this. Well, the best thing to do would be to convert this to a rational exponent and then say times x squared minus 1. And remember, when we're multiplying powers, we add the exponents. So this would be x to the 1/5. We got to think about that x squared in terms of fifths. So that would be to the 10/5 because 10 over 5 is 2 minus 1. And now just go ahead and multiply across. So x to the 1/5 times x to the 10/5 would be x to the 11/5 minus x to the 1/5. Pretty ugly answer, but it's true. And you cannot say that x to the 11/5 minus x to the 1/5 is x to the 10/5. Therefore, it's x squared. Do not do that. Whatever you do, none of that is true. Okay, this statement is true, but you can't get from here to there. That is not true. So this is your final answer. Okay? All right, moving on. Number 2. This is real simple. I mean, if you look, what did you have to do? Well, you had to distribute back here. You had to FOIL up here. And then you just had to deal with this minus sign in the middle and combine everything. So let's FOIL the first. X times x is x squared. X times 8, 8x. 6 times x, 6x. And 6 times 8 is 48. The only tricky part about this whole problem is just making sure that you realize that this is a negative and you distribute it as you should. So that really is a negative 3. So it's minus 3x and minus 12. And now let's combine everything. So I have x squared, 8x and 6x is 14x, but then minus 3x is 11x. And then 48 minus 12, 36. Done. All right. Number 3. This one you're going to FOIL as well. It's just not going to work out as clean because we have this exponent right here. So you're not going to get the 4 terms that combine down to the 3 terms. You're going to end up with 4 terms. But we still just FOIL it, okay? First, outer, inner, last. So the first, 5x times x squared is 5x to the 3rd power. Outer, 5x times 4 is going to be 20x. Inner, negative 6 times x squared is negative 6x squared. And last, negative 6 times 4 is negative 24. The one thing you should do is switch some of the order around. You should always have it in descending exponential order. So you'd have 5x to the 3rd minus 6x squared. That negative sign comes with the 6x squared. Plus 20x minus 24. There you go. Final answer. Okay, we're flying through these. Number 4. Hopefully you guys had a little bit of fun with this one, realizing at first that to say that this thing is squared just means you multiply it by itself. So you say b plus 1 over b times b plus 1 over b. Hopefully you remembered that if you have two things being added up and it says squared, that is never equal to just x squared plus y squared. That's never true. Ever, ever. Don't ever do that. Okay, that's a big mess. Don't do that. All right. Instead, you've got to think about it in terms of that whole thing times itself. And so then we just FOIL. All right. So say first, b times b, b squared. Outer, b times 1 over b. Well, that's just going to be b over b. Inner, 1 over b times b, again, b over b. And then last, 1 over b times 1 over b is going to 1 over b squared. So let's take a look at this. We'll have b squared plus b over b is just 1, and b over b is just 1. So that's 2 plus 1 over b squared. And that's our final answer. And that's actually in the proper order if you think about descending exponents, because this exponent is 2. The exponent on the b in this value would be 0, and the exponent right here is a negative 2 because the thing's on the bottom. So this would be the right order. B squared plus 2 plus 1 over b squared. All right, we're almost done. Hang in there, guys. We're just about there. Okay, 2 to go. This one is like FOIL to the extreme. You can't FOIL it. I had a student the other day try to FOIL this one, but you can't. You got to think about it as take this first term and make sure it gets multiplied by each one, by that one, by that one, and by that one. And then next, you got to take this next term right here and make sure it gets multiplied by everything. And lastly, you take this term right here and make sure it gets multiplied by everything. And so really, you should end up with 9 terms. And then some of them will probably combine. But initially, 3 times 3, you should have 9 terms. Just think about like when we have x plus 2 times x plus 3, it's 2 terms right here times 2 terms right here. So initially, we start out with 4 terms. And so now because we have 3 terms here and 3 terms here, we should initially have 9 terms. So let's go after it. We'll start with this x squared. X squared times x to the third is x to the fifth. X squared times negative 2x is negative 2x to the third. And x squared times 2 is plus 2x squared. So we've taken care of that guy. Then we move on to 2x. So we say 2x times x to the third is going to be 2x to the fourth. 2x times negative 2x is going to be negative 4x squared. And 2x times 2 is plus 4x. All right, so now we've taken care of this guy. And so then we look, and so let's look at the 3. So 3 times x to the third plus 3x to the third. 3 times negative 2x is minus 6x. And 3 times positive 2 is plus 6. And so now, like I said, look at what I've got now. I've got 1, 2, 3, 4, 5, 6, 7, 8, and 9 terms. And you should be able to count yours just to make sure you're doing this right. And now combine anything you can. This is the only to the fifth I have. So that one's going to stand alone, x to the fifth. I look and go, okay, I've got an x to the fourth, but no other x to the fourth. So I've already taken care of this one. So then I'm going to say plus 2x to the fourth. So I'm taking care of this one. I'd just cross them out as you go to try to help you keep things straight. I've got a negative 2x to the third and a positive 3x to the third. So when I combine those, I would get plus 1x to the third. So that's taking care of that one and that one. And now let's look at the squared terms. I got squared here and squared here. So 2x squared minus 4x squared is minus 2x squared. So that takes care of this one and that one. And then I've got plus 4x and minus 6x. So 4x minus 6x is going to be minus 2x. So I'm going to take care of that one, and then I just have a plus 6 on the tail end. That's it. I'm done. All right, notice the exponents are in descending order, but otherwise, that's what I had. I started off with 9 terms, and I ended up with 6 because of all the ones combining. All right, last problem. This one is all you do is FOIL. All you do is FOIL. The hard part about this one is keeping all of the exponents straight, but that's not hard. So let's look at first times first. Okay, first times first. 2x squared y times 3x squared y cubed. So 2 times 3, 6. X squared times x squared, x to the fourth. Y times y to the third, y to the fourth. So I did first. Now let's move on to outer. 2x squared y times negative 1y squared. So 2 times negative 1, negative 2. X squared, there's nothing to multiply the x squared by, so it just comes along. Y times y squared, y to the third. Took care of outer. Now let's do inner. So that's that negative 7xy squared times 3x squared y cubed. So negative 7 times 3, negative 21. X times x squared, x to the third. Y squared times y to the fifth, y squared times y to the third is y to the fifth. So I've done that, done inner. Now let's move on to last. So that's going to be that negative 7xy squared times negative 1y squared. So negative 7 times negative 1, positive 7. X comes along for the ride. Y squared times y squared is y to the fourth. Now at this point, your only job is to check to see do any of these exponents match so that I could combine any of these terms. And look, I've got x to the fourth, y to the fourth, x squared, y to the third, x cubed, y to the fifth, x to the 1, and y to the fourth. Nope, none of them can be combined. So really, I can just leave that one completely as it is. It's the descending order is, you could argue this one right here, maybe you want to move, maybe swap these two because you have x squared and x to the third. That's the only thing I might look at, but otherwise it's completely acceptable as it is. If you happen to write 6x to the fourth, y to the fourth, minus 21 x to the third y to the fifth minus 2 x squared y to the third plus 7x y to the fourth, that's absolutely fine too. Either one is completely acceptable. Well, I hope this answered all of your questions. And I think the quiz, I made sure it was matched the practice quiz very closely. And so do your best, try your best, and have a great day. We'll talk to you later.